Hi guys, it's Mrs. Smith here. I hope everybody is having a good week so far. And we are on to our next lesson, which is still in geometry. And we're now looking at line and angle relationships. And then we're also going to look at some different ways to classify triangles and different information about triangles. So we're going to start off with your most favorite thing, some fun vocab, because I know you all love it so much. So the first thing that we want to remember is that parallel lines are lines that never intersect. Okay. And some vocab that we're going to look at what a transversal means. A transversal is a line that intersects two or more lines. So if I look at this diagram here to the right, this would be my transversal. Okay, so it's intersecting two or more lines here. The other thing that you want to look at on that diagram is some more notation that we kind of have been talking about. So these triangles or these arrows on these two lines, this means that these two lines are parallel. Okay, so when you see these markings here, it means the lines are parallel. Okay, and a lot of times in the problem, they'll tell you that the lines are parallel. But again, if you see that, that also means that the lines are parallel. So when we have a transversal that cuts through two parallel lines, we have certain types of angles that are formed. So one type of angle that's formed would be corresponding angles. So these are two congruent, which means they're equal, right? Angles that have the same position on the same side of the transversal. So for example, in this diagram here, what I usually like to do for corresponding angles is I like to kind of split the top four angles and think of that as like one grouping, and then the bottom four angles and think about this as the other grouping. So if corresponding angles have the same position on the same side of the transversal, if I look at angle 1 in the upper four angles, you're trying to think to yourself, what angle has that same position in the lower four angles? So angle 1 and angle 2 would be corresponding. Okay, so angle 1 and angle 2 are a pair of corresponding angles. So same sort of thing here. I'm going to look at angle 3 in the upper right. So now in the bottom four angles, angle 3 would correspond with angle 4. So angle 3 and angle 4 would be corresponding angles. Okay, so take a minute here. You can pause the video, and I want you to write down the other two pairs of corresponding angles, and then hit play again and see if you got them correct. Okay, so hopefully you picked angle 5 and angle 6 are corresponding, and then angle 7 and angle 8 are corresponding. Okay, so angle 5 and angle 6, angle 7 and angle 8. So again, you can see how they share those same positions. And then I'm going to make this a different color. There we go. Okay, so same position, same side of the transversal. Okay, so going back up here, the parallel lines in this diagram, again, look at the markings here. So you see these two markings, these two arrows on these lines. So we know that line A is parallel to line B. So we want to write that using correct notation. So we know from last week that if we're talking about a line, you need to draw a line above it. So I know that I'm talking about line A. And then for parallel lines, the notation for that is basically these two parallel lines here. Okay, so this means parallel. Okay, so line A is parallel to line B. So again, a lot of kind of little details here when you're trying to write things and use the correct notation. Okay, and then the transversal doesn't really have too much notation. You do have to say line T, right? So we know that that's a line. Okay, so line T here is our transversal. Okay, so again, line A is parallel to line B. Okay, so we also have alternate interior angles that are formed, again, when you have a transversal cutting through two parallel lines. And again, this forms two congruent, okay, which again means equal in measurement, angles that are, sorry, two congruent angles that are blank the parallel line, sorry. And oh, sorry. This is what happens when I have to do this late at night after my children have taken all my energy. Two congruent angles that are inside. Here we go. Okay, the parallel lines. So these are the two parallel lines, right? And we're looking at the angles that are inside the parallel lines. And on opposite sides of the transversal, okay? So if I look at this, again, they need to be inside the parallel lines and on opposite sides of the transversal. So angle 5 and angle 4 would be a pair of alternate interior angles. And then also angle 7 and angle 2 would be a pair of alternate interior angles. Okay, so angle 5 and angle 7. And then we also have, oh my goodness, angle 5 and angle 4, and then also angle 7 and angle 2. All right. So we also have alternate exterior angles. Okay, so again, when a transversal cuts two parallel lines, it's going to form two congruent, okay, or equal angles. And now this time that are outside the parallel lines and on, again, opposite sides of the transversal. Okay, so if we look at the angles that are outside of the parallel lines, we would be looking at 1, 3, 6, 8. Okay, so we want the angles that are on opposite sides of the transversal. So angle 1 and angle 8 would be a pair of alternate exterior angles. Okay, and then we would also have angle 3 and angle 6. Okay, so alternate interior on the inside of the parallel lines, alternate exterior on the outside of the parallel lines. Okay, and again, when the transversal cuts the two parallel lines, all of these different types of angles are equal to each other. If it wasn't cutting through parallel lines, it would not create angles that were equal. All right, so we also have adjacent angles. So adjacent angles are two angles with a common vertex, okay, and common side that do not intersect. Okay, so if I look at this diagram on the side, I would say angle WXY, okay, is adjacent to angle YXV. Oh my goodness, YXZ. I think my brain is gone for tonight. So I apologize for what might come next. Okay, so it has the common vertex, right? The vertex, remember, is X here, where the two rays come together. And they also share this common side here of XY. Okay. And adjacent angles don't share the same measurement. So there's nothing, like there's no common thing that we know about adjacent angles and their measurement. All right, so we're going to look at an example here, and we're going to go through and look at if they're corresponding, alternate interior, alternate exterior, vertical, which remember vertical means they're opposite, or adjacent angles. So angle 2 and angle 3, these angles would be opposite of each other, so they're vertical. Okay, and this would be a point where if you want to do this on your own, you could go ahead and pause the video and then try to fill it out on your own and then play it again to make sure that you got it correct. Okay, so go ahead and do that if you would like to. If you want to kind of do it together, that's fine. So angle 4 and angle 5, these are inside my parallel lines on opposite sides of the transversal. So these are alternate interior angles. 1 and 8 are outside of my parallel lines on opposite sides of the transversal. So those are alternate exterior angles, and it's fine if you want to abbreviate. Angle 2 and angle 6. Okay, so again, if I kind of split these into the top 4 and the bottom 4, angle 2 and angle 6 share that same position. So those are corresponding. Angle 3 and angle 7, again, same sort of thing. Those would share that same position, so would also be corresponding. Okay, so now if I look at angle 3 and angle 6, I'm going to get rid of this for now. So angle 3 and angle 6 are on the inside and they're opposite. So angle 3 and angle 6 are alternates interior. Okay, angle 5 and angle 8, again, are just opposite of each other. So those would be vertical. Angle 1 and angle 2, they share that common vertex and the common side. Okay, so those would be adjacent. Sometimes people will say, okay, those are supplementary, which they are because they form a 180 degrees. But again, look at how they're asking you to classify it. They're not asking you to classify that as supplementary right now. Okay, angle 1 and angle 4 would be another example of vertical angles because they're opposite of each other. Angle 4 and angle 8 would, again, share the same position if we put the top 4 and the bottom 4 angles. So these would be corresponding. Angle 6 and angle 7 are opposite of each other, so they're vertical. And angle 6 and angle 8, again, share that common vertex and the common side here, so these would be adjacent. Okay, so if you did that on your own and you're checking, hopefully you got those answers or you corrected anything that you didn't have here. All right, so this next part says find the measure of the numbered angles in the diagram. So we talked about the different types of angles that were corresponding, or sorry, that were congruent and equal in measurement. So there's a lot of different ways that you could do this. So for example, for number 13, I could say, okay, this angle that's 75 degrees here and angle 3 are corresponding. So because the transversal cuts the two parallel lines, I know that angle 3 has to be congruent to its corresponding angle of 75. Okay, angle 75 and angle 2 are alternate exterior angles. So again, those are also congruent. Okay, I could also say angle 75 and angle 6 are vertical, and I know that vertical angles are congruent. So I could say that this is 75 degrees as well. All right, so now I'm going to have to use something different here. So now I'm going to say, okay, angle, let's just say this 75 and angle 7, these are supplementary angles because they form this straight line here. So they have to sum to 180 degrees, which means that this is 105 degrees.